This is Module 1, Lesson 24, Applications of System of Equations and Inequalities. This first exercise is not in your notes, but it's a very good practice problem. It says the difference between two numbers is 9. So we're going to have to write this out algebraically. The difference meaning subtract, between two numbers, so I'm just going to pick x and y, is 9. The first number, so x in this case, plus twice the other number is 27. So before I do anything with this, I need to define my variables. X equals one of the numbers, and y equals the other number. So now I need to solve my system. So we've learned 3 ways, but since we most recently learned elimination, let's focus on the elimination method. So if I look at my x's here, I can easily eliminate my x's by distributing a negative all the way through to either of these. So I'm just going to choose the bottom. So my new bottom equation would be negative x minus 2y equals negative 27. Bring my top equation over, x minus y equals 9. Now I can solve this. My x's cancel out. X minus x is gone. Negative 1y minus 2y is negative 3y. And 9 minus 27 is negative 8. Now I'm going to divide by negative 3 to isolate my variable. Y equals 6. Now I'm going to plug in that value I just found to either of the equations, my original system, to find the other value. So x minus y, we just found y, 6 equals 9. Add 6, x equals 15. So since this is a word problem, we're not going to write our solution as an ordered pair, so to speak. We're going to write it in words. So the numbers are 15 and 6, or 6 and 15. It doesn't matter the order you write them in. The question said find the two numbers. Now let's look at the opening exercise in your notes. In Lewis Carroll's Through the Looking Glass, Tweedledum says, the sum of your weight and twice mine is 361 pounds. Tweedledee replies, the sum of your weight and twice mine is 362 pounds. Find both of their weights. So we first need to define some variables. So let's let x equal Tweedledee's weight. And let's let y equal Tweedledum's weight. Okay, I'm underlining the D and the dum just so that we can easily refer to it since they're such similar names. So now let's go back to the context of what they're saying here. So Tweedledum says the sum of your weight. So he's talking to Tweedledee, whose weight is x. So the sum of your weight, so x and twice mine. This is Tweedledum talking. So plus 2y is 361. Then Tweedledee replies the sum of your weight, so he's talking about Tweedledum, which is y. The sum of your weight, y, and twice mine is 362. Find both of their weights. Okay? So the first observation you should be making on this system is that we have a system, but our x's are not aligned and our y's are not aligned. So let's rewrite this bottom equation so that our x's come first. So y plus 2x is going to become 2x plus y. So that they are all in alignment. Now let's look at our system. What can we do to solve this? I'm going to choose the elimination method, and I'm going to multiply the top by negative 2 so that I can cancel my x's. So my new x would be negative 2x minus 4y equals negative 722. I'm going to bring down the bottom equation. 2x plus y equals 362. Now I can solve this. My x's cancel. Negative 4y plus y is negative 3y. And negative 722 plus 362 is negative 360. Divide by negative 3, y equals 120. So as a reminder, y is Tweedledum's weight. So this is Tweedledum's weight. Let me come back to it in a minute. Now we need to plug Tweedledum's weight in to find Tweedledee's weight. So again, it doesn't matter which one you use, so I'll just use the top. X, we don't know what x is. X plus 2 times y, we just found what y was, equals 361. So this would be x plus 240 equals 361. Subtract 240, x equals 121. So in words, since this is a word problem, very important, Tweedledee is x. Tweedledee weighs 121 pounds. And Tweedledum weighs 120 pounds. So this problem could have been very confusing had you not defined your variables from the very beginning. So it's always important that you define your variables and actually show me that you are defining your variables. So let's look at the next example. Lulu tells her little brother Jack that she is holding 20 coins, all of which are either dimes or quarters. They have a value of $4.10. She says she will give him the coins if he can tell her how many of each she is holding. Solve this problem for Jack. Okay, so let's define some variables. We've got dimes and quarters. So let's let D represent dimes. So D represents 1 dime, and Q is going to represent 1 quarter. Okay? So, if we know we have 20 coins, then we know that some dimes plus some quarters is going to equal 20. So there's one equation. We also know that when we add up these dimes and we add up these quarters, we're supposed to get $4.10. So that's going to be a total here. And we know each value of a dime, whether they tell us that or not. We know a dime is 10 cents, which we can mark as 0.10 D, plus a quarter is 0.25 Q. So now we have a system. So we need to solve this. So again, this time I'm going to solve this one again by elimination. But again, you can use any method here. So I'm going to multiply the top by negative 0.10. So that way my D's can cancel out. So my new top equation would be negative 0.10 D minus minus 0.10 Q equals negative 2. Bring down the bottom. So as you see, hopefully, my D's cancel out. Negative 0.10 plus 0.10 cancels out. Negative 0.10 plus 0.25 is 0.15 Q equals 2.1. Divide by 0.15 on each side. Q equals 14, which means we've got 14 quarters. And now we need to figure out how many dimes we have. So let's plug this value back in. So I've got D, we don't know what D is. D plus Q, we just found Q, is 14, is going to equal 20, which means D equals 6. So in words, again, you need to write your solution in words, since it's a word problem. Jack has 6 dimes and 14 quarters. Let's look at the exploratory challenge in your notes. Part A says, at a state fair, there is a game where you throw a ball at a pyramid of cans. If you knock over all the cans, you win a prize. The cost is three throws for $1. Okay, so $1 gets you 3 throws. But if you have an armband, you get 6 throws for $1. Okay, the armband costs $10. Write 2 cost equations for the game in terms of the number of throws purchased. One without an armband and one with. So let's let x equal the number of throws here. So x is going to represent number of throws. And let's let c equal the cost. So without an armband, okay, without the armband, so without an armband, the cost is 3 throws for $1. So let's start this with C equals, so our cost equals 3 throws for $1. We can write that as a fraction. For every $1, there are 3 throws. With an armband, again, we have a cost equals, this time, you get 6 throws per $1 with an armband. But the armband costs you $10. So the armband alone is going to cost you $10. So I would start with the 10 plus 6 throws per $1. So for $1, you get 6 throws. So if we wanted this to look like it's in slope-intercept form, it would be C equals 1 over 6 x plus 10. So part 3, we're skipping part 2. Part 3 asks, does it make sense to bind the armband? Okay, the only way we can answer that question is if we solve this. Okay, so let's think about how we might easily solve this problem. If you look, both of our equations are C equals, kind of like Y equals. So it would be easiest to solve this by substitution because we can just go ahead and take one of these and substitute them in for the other C. So we would have 1/3 x equals 1/6 x plus 10. Let's subtract 1/6 on both sides to get our x's together. So we are left with 1/6 x equals 10. And 10 divided by 1/6 is 60. So x equals 60, and if you remember from our variables, x means throws. So this is 60 throws. So it only makes sense to buy the armband if we plan on throwing more than 60 times. These are practice problems. These are not in your notes, but I highly, highly encourage you to write these down, find a way to complete them. So if you want to pause the video and try to work through these, I would encourage you to do that. So let's look at number 1. The cost of 12 oranges and 7 apples is $5.36. 8 oranges and 5 apples cost $3.68. Find the cost of each. So again, the first thing you want to do is define variables. So let's let O equal an orange, and let's let A equal an apple. So again, your variables don't have to be the same, but you must define them, even if this may seem obvious. So 12 oranges, so 12 O plus 7 apples is $5.36. 8 oranges and 5 apples is $3.68. Find the cost of each. So we need to solve this system. So based on this system we have here, there's nothing I can multiply the top or the bottom by just once to eliminate the O's. And the same thing for A's, which means we're going to have to multiply both equations by something. So let's multiply the top by 5, so I can focus on getting my A to be 35. And that way I can multiply my bottom by -7. So if you look, all I did was take the A coefficients and multiply by the opposites. So now I need to change both of my equations here. So my new equations are, the top would be 60O, make sure that doesn't look like 600 on your paper, plus 35A equals 26.8. My new bottom would be -56O, again, make sure that doesn't look like -560, minus 35A equals -25.76. So if you now look at my system, since I had to multiply both equations, I am in the position to cancel out my A's. 35A minus 35A is gone. 60 minus 56O leaves me with 4O equals 1.04 divided by 4. O equals 0.26. So an orange is going to cost me 26 cents. So now I need to see how much an apple is going to cost me. So I'm going to plug in that value. So 12 times O, 12 times 0.26, plus 7A equals 5.36. So I'll multiply that and subtract it by 5.36. I'm left with 7A equals 2.24. After I subtract it from that side, divide by 7, A equals 0.32. So again, in words, it's very important that you write it in words. An orange costs 26 cents each, and apples cost 32 cents each. Sorry, we're running out of room here. You have to write it in words. Let's look at number 2. A garden supply store sells 2 types of lawnmowers. The smaller mower costs $249.99, and the larger mower costs $329.99. So let's go ahead and define our variables. So I'm going to let S equal the smaller mower, and L equal the larger mower. And I'm going to represent this with a capital L because the lowercase l looks like a 1. So 30 total mowers were sold, which means my smaller mowers plus my larger mowers are going to equal 30. And we know a smaller mower costs $249. $249.99. So I can write that now as $249.99 smaller mower plus $329.99 for a large more is going to bring in a grand total of $8,379.70. So to solve this, it's going to be a bit rigorous, but you can handle it. I'm going to use the elimination method again. So I'm going to multiply the top equation by negative 249.99. So that way I can eliminate my s's. So I've got negative 249.99s minus 249.99l equals negative 7499.70. Because remember, you're distributing this value all the way. I'll bring down my bottom one. My s's cancel. Negative 249.99 plus 249.99 cancel. I'm left with 80L equals 880. Divide by 80, L equals L, 11, excuse me. I'll plug that in now to find my smaller molar amount. So I've got S plus L, I just found L, which means S equals 19. So again, in words, how many of each type were sold? 11 larger mowers were sold and 19 smaller mowers were sold. Let's look at another practice problem. Miss Miller decides to give a test worth 90 points and contains 25 questions. Multiple choice questions are worth 3 points and word problems are worth 4. So we've got two types of questions. So let's let M equal a multiple choice question. And let's let W equal a word question or a word problem. Okay, so I've got 25 questions. So I know my multiple choice questions plus my word problem questions are going to equal 25. I also know that this test is worth 90 points. And a multiple choice question is worth 3 points, so that's 3M. And a word question is worth 4 points, so plus 4W. So now I want to solve this. So I'm going to use the elimination method again. I'm going to multiply the top by negative 3, so I can eliminate my m's. So my new top equation is negative 3m minus 3w equals negative 75. Bring over my bottom. Negative 3w plus 4w leaves me with 1w equals 15. So I've got 15 word problems. So now let's plug that back in. Multiple choice questions plus word equals 25, which means I've got 10 multiple choice questions. So again, in words, we would write, there are 10 multiple choice and 15 word problems on the test. So you have to make sure you write your answer back in the context of the problem. Let's look at number 6 here. The sum of two numbers is 20. So this is really similar to that first exercise we did. Oh, sorry. The sum of two numbers is 20. So let's just pick x and y. X equals one number. Y equals the other number. So the sum of two numbers is 20, so x plus y equals 20. The difference between 3 times the first number, so 3 times the first number, and they said difference, and twice the second is 40. Find the two numbers. So again, I'm going to use the elimination method and multiply the top by -3 to cancel out my x variables. So my new x will be -3x minus 3y equals -60. Bring over the bottom. So my x's cancel. -3x plus 3x is gone. I've got -5y equals -20. Divide by -5y equals 4. I now need to plug this back in. I'm looking for x plus 4 equals 20. So x equals 16. So my two numbers, the numbers are 16 and 4, or 4 and 16, however you want to look at it. Again, this is applications of system of equations and inequality, so I encourage you to, you can do a simple Google search to find additional practice problems for more